Start. Okay. That day, we had started with probability. Okay. So what we had studied, we had started with probability.
Yeah.
And in probability, we had first seen its terminology. So first terminology was sample space. So sample space, that was denoted by, when we write it, it is denoted by S. So what is the definition or what is the meaning of a sample space? What space it is? The space of all possible outcome, or you can say space or set of all possible. All possible means all the things that are possible outcomes of an experiment or task, you can say, experiment or task, without repetition of the outcomes. Without repetition of the outcomes. Of the outcome means what? Of the changing here. Okay. Without repetition of the outcome means what? Every I'll write in bracket, every outcome in the sample space, every outcome in the sample space must be unique. Must be unique. For example, we'll see one example of tossing two coins. Example, tossing two coins. Okay. So what will be the sample space? HH. Okay. First, this is the first coin. This is the second coin. HT, TH, and TT. For example, we are doing experiment and one more TT comes. So it will be in an event, but it will be not repeated in a sample space. There will be only one TT. There cannot be two TT in one sample space because they are similar. Yes, there comes a question that this and this are also similar, but it is not similar because here on the first coin head is coming and on the second coin tail is coming, and here on the first coin tail is coming and the second coin head is coming. Therefore, they are different. So identical things and identical outcomes are not repeated. Is it clear? So that's the thing. Sample space. So next is event. The most second important thing is the event. So what's the event? We'll look into first of all text, what he has defined the event. A model is description. Okay, we have seen probability, sample space we have seen, probability model we have seen. Okay. Okay. Event is any collection of outcomes for some random process. It is a collection of some outcome. They see here, all and some. There is a big difference. I'll mark the definition here. Means mark the important words. All, and it is here. It is a collection. It is a set, or you can say set or collection of some outcomes for a random process, for a random process. Okay, means what? I have given you a task that for example, I'm tossing two coins. So what will be the sample space, by the way? So S will be HH, HT, TH, and TT. For example, I have given you event 1 means a random process for this sample space, that my event 1 means my random process is such that it must have both the heads. So what will be the space for event 1? It will be only HH. No other 3 will come in this event. So this is some outcomes, means depending on the condition, on conditions when processes are done. When process are done. When random process is done. Sorry. When random process is done is known that then it is known as event. Then it is, I'm giving you different definitions. Then it is known as event.
Yeah, okay.
Okay. That,
Okay.
so it, what was the condition here in this E1? That both the coins should must have head. Okay, I'll make one more E2 that I'll write in wordings here. So wordings one, yeah, when you learn set theory in mathematics, wordings one is called as set builder form. Means when we write event or
Mm-hmm.
sample space in wording, it is known as set builder form. And when we write down like this, or I'll make a note. So E2 is it must have at least one tail. At least one tail. So at least one tail means we'll look into the sample space. What was the sample space, by the way? At least one tail means, see here. It has at least one tail. It has at least one tail. It has at least one tail. It does not have at least one tail. So this will be skipped. All these three outcomes will be in our E2. Yes. So it will be
Mm-hmm.
TH, HT and TT. See, both TT are why they are coming? Because at least is he has told. Yes or no? So more than one
Yeah.
is also accepted. So see here what I was trying to explain. This in wordings when event or set is written, this is known as set builder form. And the same thing when we write in the form of elements, it is known as roster form. So I'll write the spelling ROASTER. Roster. Understood? Understood?
Yeah.
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 Just give me a minute. Just a minute.
Mm-hmm.
Okay. So that was event. Yeah, the thing of event is
Mm-hmm.
the concept of event is clear.
Yeah. Yeah.
So we'll read. A probability model does more than just assign a probability to each outcome. It also allows us to find probability of an event. So we can find the probability of the specific event. So we'll see what's the formula. So I'll just give you the formula as well. Probability of event is equals to
Mm-hmm.
uh, number of elements in event upon, and on what basis, see your event on what basis it was, means what was the sample space for this event that we had conducted E1 and E2. It was a sample space of what you will say, tossing of two coins. So number
Mm-hmm.
of elements in the event upon number of elements in the sample space. Number of elements in the sample space. That's the formula.
Yeah.
So what is necessary for conducting any event? So necessary part is necessary. So for conducting any event, sample space is compulsory. Sample
It's
space,
compulsory.
yeah, is compulsory, because without having a sample space, we cannot predict the elements of that event. Compulsory. That's it. Understood? So, and without sample space and without number of elements in the event, we cannot calculate the probability also. That's the thing. So events are
Mm-hmm.
usually designed by capital letters. So generally events are written. Sample space S is also written by S. Sample space, sample space is generally written by capital S, and events are generally written events. Generally, some in some textbooks they write as capital A, B, C, D till Z, or they use like this E1, E2 with subscripts as numbers, EI. they use like this also. So not to be confused, just there are capital letters in used in an denotation of an event. Okay, so that's the thing. So what he is telling, okay, we write the probability of event as P of A. Okay. Events are usually designed by capital letters like A, B, C, and so on. For rolling two-sided dice, we can define event A as getting a sum of 5. Two, two six-sided dice. Okay. So our experiment is rolling off two dice. Rolling off two dice. So what will be our sample space? Just you have to not write the sample space every time, but you have to write one time at your home and remember that in your exam. So what's the general sample space? 1 1 1 2 like this, and we'll write once the whole sample space, by the way, so it will be clear to you. 1 6 how to write. Then next line I'll have a comma. 2 1 2 2 2 3 2 4 2 5 and 2 6. Then 3 1 3 2. These are all the possible outcomes when rolling a two die that I am writing here. 3 5 and 3 6. 4 1 2 4 5 5 1 5 2 5 3 5 4 5 5 5 5. Calling 6 1 calling 6 2 6 4 6 5 and 6. Okay, so that's the whole sample space of rolling off a two die. So what's the event that he has given us? C here. So he'll get a boy has rolled two die. What is the probability? When he has said that, what is the probability? What is the probability of? For suppose I'm giving a question. What is the probability of? What is the probability of? So there will be an event. For example, the sum of the upper faces should be 5. The sum of the upper faces, upper face must, the sum of the upper face, sum of the upper face must be 5. So we look into the, for example, this is our event A. This is our event A. So what will be the, I have to find the probability of this event. So I need to find how many elements are there in this event. So I look into the sample space such that, see, these are the upper faces that are listed in the sample space, that when we will roll a die, what are the possible outcomes in the things. Okay, so where the sum is 5, see here, I'll mark it 1, okay, 2, okay, 3, 4, then 4, then your just a minute, Zayla, just a
Mm-hmm.
So see, this all probably are the, what you'll say, possible outcomes. So 1 4. So in our event it will come 1 4, 2 3, okay, then 3 2 and 4 1. See, I'm telling you, this and this are different. Okay, this and this are different because 2 is on the first die and 3 is on the second die. Same as well. 4 is on the first die and 1 is on the second die. No other outcome is there. We suppose this event. So I need to find the probability of A. So the probability of A will be number of elements in A. So how many elements are there in A? 4, correct?
Mm-hmm.
Yeah. And total number in, what you will say, sample space is 36. See how you will calculate. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 into 6. 6 rows into 6 columns is 36. So 1 by 8. Very good. Yes.
1/9.
That's the probability is
So we put 1/8.
0.18. Yeah. 1 8
We
or
put
1 2.
1/8.
1 2 na 0.12.
You put 1/8, not 1/9.
Ha 1 9. Yeah. 4 ones are 4, 4 nines are 36. Yeah. So 0.111. It's 0.111. That's the probability. Means around 11.11%. That's the thing. Understood, Zaid? How to calculate the probability and
Mm-hmm.
all? It was an interesting question, by the way.
Yeah.
So I'll give you one more task. That then what is the calculating the probability and all will be clear on the same sample space, such that find the probability such that it's all year. Find what is the probability of. Then first sub question start. Then this is the second question sub question that I'm giving you. Find the probability of uh, the absolute difference on the upper face is 3 is 3. So what is the difference between what is the difference between difference and absolute difference? What is the difference between these two? Can you explain me? Tell me just what is the difference? Means what does just difference means if I'm writing difference, and what is the meaning of absolute difference?
Absolute difference means the exact difference. Difference
Exact difference.
can vary.
No. Absolute difference means mod. What does mod does? Mod of minus 3 is 3. What does mod do? It absorbs the negative
It
sign. So
makes it
absolute
positive.
difference. Yes, it makes the negative also positive. So absolute means if I'm doing 6 minus 3, it will be 3 here in absolute difference. If I'm taking here absolute difference, this mod is known as absolute difference. When we apply mod to the subtraction, then it is known as absolute difference. And 3 minus 6, mod of 3 minus 6, it will also be positive 3. So that's the thing. But it will not be the case here when I'm telling just difference. So 6 minus 3 will be 3 and 3 minus 6 will be minus 3. So that's the difference between difference and absolute difference. So what I have listed here, absolute difference. So I'll write B equals to, so I want the absolute difference to be 3. So 1 comma 4 will be included in it. 4 comma 1 will be included in it. 2 comma 5, 5 comma 2, correct? See here, 2 comma 5 is minus 3, but he has told absolute difference. That's the reason we are including it in it, this in it. So 2 happens, 3 in 3 will be 3 comma 6, 6 comma 3. Any more you can think of, Zaid? See, I've listed all the one. You can see the sample space. Any more that you can think of that when you will subtract, you'll get the 3 as absolute difference? No, there are no 5 comma 2 and 2 comma 5 we
Oh,
have listed. Yes. So how many probability of B we need to find? So probability of B equal to how many elements are there? There in B 1, 2, 3, 4, 5, 6. So it's 6 upon 36.
36.
So 1 by 6. Yeah, that's clear. Yes or no?
Mm-hmm.
Okay. So finding probabilities, equally likely outcomes. So if all outcomes in the sample space are equally likely, the probability that event A occurs can be found using formula number of outcomes in event A upon total number of outcomes in the sample space. Means what? When the die is fair, means when the die is fair and the sample space, see, the what is the probability of coming this as an output? So it is 1 by 36. What is the probability of this? It is 1 by 36. All the elements in the sample space have equal probabilities of coming out. Yes or no when a die is rolled? That's the thing. So when there is an equally
Mm-hmm.
likely possibility of all the outcomes, means it is a perfect probability model, simple probability model, then we can use this formula. Because further we will be seeing conditional probability on all. Means some condition will be there on the outcomes. Means that, for example, I'll fix the first die, that the first die is 1, that the first die is 1, means all the outcomes have zero probability now. Yes or no? All these outcomes will be having
Mm-hmm.
zero probability. Yes or no? That's the thing. So
Yeah.
conditional probability when comes into picture, we will have some different formula by the thing. Okay. So here all the outcomes in the sample space have equal probability. So we can apply this formula on any event. That's it. Is it clear? Okay.
Yeah.
So going to the next topic. So finding probabilities of equally likely, the formula that's also I've made clear. Eventually, okay. Now you'll read the question and tell me. Okay, come on. You have to give me the answer. Okay, so we'll see into it how to. That's probability model and all the definition is very clear. We'll do one sum and all the things will be clear there. Are you there, sir? Yes or no?
Yeah, I'm there.
Okay. So what's a probability model? Probability model means you have to just write the sample space and list down all the outcomes of the sample space by listing it down. Okay. That is the main thing of the probability model. Maximize it. So a spinner has three equal. See, a spinner has three equal sections. Three equal sections means the 360-degree pie chart is divided into three equal parts: 120-degree, 120-degree, and 120-degree. Okay. So means they are equally likely. Yes or no? What is the probability of
Mm-hmm.
this to be coming? 120 upon 360, 120 upon 360, 120 upon 360. But here, what is the thing? First of all, a spinner has three equal sections: red, blue, and yellow. Suppose you spin the spinner two times. So how much I have to spin the spinner? Mean what is the experiment? Experiment is spin the spinner, spin the
Mm-hmm.
spinner two times. So two times. So when I'll spin the spinner two times, what are the possibilities of the in the sample space? So it may happen that it may come red, red, it may come red, blue, it may come what you will say red, blue, and yellow. Okay, it may come red, yellow. Okay, so it may happen yellow, yellow. It may happen yellow, red. It may happen yellow, blue. It may happen blue, blue. It may happen blue, red. It may happen blue, yellow. Yes or no?
Mm-hmm.
So these are all the possibilities that are listed here. Correct?
Yeah,
So
okay.
give a probability model for this random process. So that's the probability. What we have to do in a probability model, we have to write each of the what you will say outcome and write its probability. What will be the probability of it? How many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's I think 9. It should not be 9. 1, 2, 3. Okay, yellow. Okay, 9. 1 by 9. RB also will have 1 by 9. So that is the probability model where the outcomes and all are listed. So we'll see the answer. What's given here? See. So sample space will be this because the spinner has equally likely outcomes. Each of these outcomes, see, he has written all the things in one sentence that because of the spinner has equally sections, so all of the outcomes will have the equally likely probability. That's 1 by 9 that we were writing individually here. He has written in one sentence that as the spinner, the spin part is equally likely and has equal parts of it. So all the outcomes of the sample space will have the probability 1 by 9. That's the thing. So, and
Yeah.
what's the second question? Defined event A as spinning blue at least one. Spinning blue at least one means what? When I have spin and find P of A. So blue is at least one times. So blue is at least one time. So this will be the main outcome: 1, 2, 3, 4, 5. Correct? Yes or no? 1, 2, 3,
Yeah.
4, 5. Anywhere no blue is there, so 5 by 9. 5 upon 9. Probability of A. Yes or no, Zaid? Is it clear?
Yeah.
Yeah,
Mm-hmm.
that's so simple. That was simple. So we'll see the answer. That's C, 5 by 9. That's it. Okay, that was very interesting. Okay. Now there are some rules. We have seen some rules further also. Just I'll give a recap of you. So what's the rule of some basic probability that we have seen? Probability. So probability is always, please manage the spelling better. So probability is always greater than 0 and less than 1. That probability cannot be negative. Probability, I'll write the points. Probability cannot be negative. Okay. Second is probability cannot exceed the value of 1. Probability cannot
Mm-hmm.
exceed more than 1 and decrease less than 0. It is always between. It is always between 0 and 1 and cannot be negative. That means cannot be negative, but I'm just listing the points as it is fits in your brain. Cannot be negative. Is it clear?
Mm-hmm.
Yeah. That was the rule. So now we'll see some of the rules that he's listed here. So basic probability rules. Our work so far suggests three comments rules that a valid probability model must obey. So if all the outcomes in the sample space are equally likely, then the event of that, then the probability that event A occurs is. So if all the, what you will say, events in that is equally likely in the sample space. So the formula we have learned that the formula is number of outcomes in event A upon number of outcomes in the sample space. Okay. So the probability of any event is a number between 0 and 1. These rules follows from the definition. I've told you, we have looked further in the starting. It is between 0 and 1. Yes or no? And when the probability is 0 means it is impossible event, and when the probability is 1 means it is sure event. Okay. All possible outcomes together must have probability add up to 1. This I have to explain you. Means what? Means
Mm-hmm.
when you consider a sample space, when you consider the sample space, here each element is having probability 1 by 36. Yes or no? Yes or no?
Yeah.
Yeah. So each outcome is having a probability 1 by 36. How many elements are there, say, in this? 36 are there?
Yeah, there is six.
36 into every element is having probability 1 by 36. So when you add 1
Which
by
is one, right?
36 plus 1, yeah, 1. So that's the addition of 31 by 36, 36 times. So I have written 1 by dot plus 1 by 36. This all is 36 times, 36 times. So I can write it 36 into 1 by 36, it's 1. Means the addition of, that means, what is the rule by the way? Addition of all the outcomes, addition of the probability, addition of the probability of all the outcomes of all the outcomes when added, it sums up to 1. It always sums up to 1. Means up to 1. If it is coming 0.99999, then also the model is the PB, probability model is incorrect. Is incorrect. Got it? It must come, all the addition of probability of the sample space should come up to 1. So the probability that the event does not occur is 1 minus the probability that the event does occur. Means what? That's a, what you will say, having and not having. Means what? For example, I am finding the probability of A. So what's A complement? For first I'll write A. A is for suppose uh, uh, head comes on the upper face. Head comes, sample space is
Wait,
one
can you give
coin
me
is
1
tossed.
minute real quick?
Yes, I'll give you one.
Okay, bye.
So, for example, the sample space is one coin is tossed. One coin is tossed. So, for example, I've tell you an event that head comes on upper face. Head comes on upper face. So, what's the sample space? I'll write the
Mm-hmm.
sample space in short, HT. So, what will be your A? It will be H, correct? So, what will be A complement?
Mm-hmm.
Complement means the opposite of A. Head does not comes. Head does not comes. Head does not comes on upper face. On upper face. So what will be the sample space, by the way? First, before calculating the probability. So it will be tails. Yes or no? Tail. Correct?
Yeah.
So what is the probability of A?
Yeah.
It is half. Yes or no? So if you want to find the probability of
Mm-hmm.
A bar, so generally probability of A complement A bar is 1 minus probability of A. So what it will be? See, 1 minus half. So it is half. Yes or no? And if you
Mm-hmm.
generally count the probability of this, so it will be half. Yes or no? So that's verified. The formula.
Yeah.
So means what he's trying to explain you that probability of not occurring. This is not occurring. Not occurring means opposite of occurring. Yes or no? Not occurring is opposite of occurring. Is 1 minus probability of occurring. or you can write the formula simply as probability of occurring plus probability of not occurring is always 1. Understood?
Yeah,
Clear?
understood.
If you want to see some more
Yeah.
examples, we see. Sum is not
Okay.
5, sum is 5. That's the thing. Okay, so it is also known as complement of A denoted by AC, or you can write as A bar also. Not a problem in that.
Okay.
So complement rule here he is given. So what is complement? It is the opposite of the main, what you say, the event. If it is coming, not coming, having, not having. Sum is 5, sum is not 5. Sum is 6, sum is not 6. Tails comes, tail does not come. It is always opposite in negative sense. Complement is always negative. Complement
Uh-huh.
complement is always opposite, or you can
Yeah.
say opposite or negative. An event of that event denoted by denoted by AC or did clear say? Yeah. Okay. Another common
Mm-hmm.
notion for A complement is A dash also. A bar, A dash, AC. Likewise, A dash. That's also known as complement. So that's the thing. So let's consider one more event involving the random process of rolling two fair six-side dice, getting a sum of 6. So for suppose probability of such that the sum of the upper faces sum is 6. So its probability is 5 by 36. 5 upon 36. Can you tell me what will be the probability of sum is not 6? See, when we'll look into the sample space, there will be many outcomes whose sum is not 6. Yes or no? So it will become difficult.
Mm-hmm.
So it is easy that we'll calculate sum is 6, and what we need to do then? It is the complement. So we need to do 1 minus 5 upon 36. Yes or no?
Yeah.
Yeah. So what will be the answer? Tell me.
It will be just 31
Correct?
over 36.
Correct. And you
Yeah.
notice that probability of sum is 6 and plus probability of sum is not 6. Sum is not 6. So what is the answer? 31 upon 36 plus 5 upon 36. When you'll add it up, so it is up around 36 upon 36, which I've told you. It's around 1. Yes or no? The formula is also verified.
Mm-hmm.
Okay, so that's the thing.
Yeah.
Okay, so sum is okay. That's one more question. What is the probability with that we get a sum of 5 or a sum of 6? Sum of 5 or a sum of 6? That's a very interesting question. Means we need to fabric probability that the sum is 5 or sum is 6. So what is the formula for it? We can distribute it by plus sign. Sum is 5 plus I can distribute the or by plus sign plus probability of sum is 6. And we can find the individual probability of 5. You know it is, I think, 4 by 36 we have calculated it. So it is 4 by 36 and it is the probability that the sum is 6. It is 5 by 36. So the total is 9 upon 36. So what will be the answer of the sum is 5 or the sum is 6? So or is the rule. Remember the rule. Or in probability, if it is having or inside, we can distribute it as P plus for A or B. So it can be written as probability of A plus probability of B. You can note it down this thing. This is important for you will require it in your calculations. Is it clear?
Mm-hmm.
Okay. Okay. So just give me 1 minute. I'll be back.
Yeah, okay. Got it.
Okay, I'm back, Zaid. So now we'll
Mm-hmm.
study some what you determine again the terminologies or some specific task in probability, or you can say sets. Generally, all the things revolve around sets. So the thing is mutually exclusive, na? Okay. So first
Mm-hmm.
of all, we need to look at mutually exclusive events. Mutually, what we have done here, we have added, na? So is this addition correct? So we need to see that. If there is a concept mutually, that's the last thing that we'll see. Mutually exclusive. What is mutually exclusive event, by the way? Is my voice correct? Or am I audible?
Yeah.
Yes, some background noise came. Okay, no problem. So mutually exclusive event. What is mutually exclusive events, by the way? So when there are two events, for example, I'll draw a Venn diagram. This is known as a Venn diagram. When you draw a diagram, that's known as a Venn diagram. Remember this also. This is all there in
Mm-hmm.
set theory. There is a subject in mathematics known as set theory. So this is all there in set Venn diagram. VENN. VENN. Venn diagram. So it's set A and this is set B. For example, 1, 2, 3, 4, and it is having 4, 5, 6, 7, 8. So we term, is there any common point between A and B? Common point. Wait, just a minute. Huh? Common common point in A and B. It is denoted as this whole sentence. Means when we need to find a common point in A and B, it is denoted as A intersection B. A intersection B. Have you learned this intersection and union in your lower classes?
Yeah.
Yeah, then it's simple, no problem. Yeah. So A intersection B. So what you have to see in the intersection, is there any common point in A and B? Can you see any common point in A and B? Say common
Four.
element? 4. Yes. So the A intersection B will be the Venn diagram I'll draw. It will be 4. Or you can write it is in set form as 4. You can write this set also in Venn
Mm-hmm.
diagram in set form 1, 2, 3, 4. And this also in event form or set form you can tell 4, 5, 6, 7. So A intersection B is 4. So when
Mm-hmm.
there is, I've given you this. You know now you are aware of the intersection. Now I'll draw C and D. C and D. Okay. So A, B, C, Z, E, and then F, K, L, P, E. Okay. E, no E,
Mm-hmm.
no E. You don't need So now we need to find C intersection D. So C intersection D. D. C intersection D you can find. A intersection C you can find. Okay. Then B intersection D you can find. That's A intersection D you can find. So in C intersection D, is there any common point? No
There's a
common.
common point, and
Is there any common point in
pretty
C and D?
sure is that E?
No, no. Here it's C. See here, I'll write it in same form. A, B, C, E, Z, and here it is F, K, L, and P. There is no common point. Yes or no? So we'll write the empty set
No,
as like this.
it's an empty set.
Empty set, empty event, and we also denoted this by phi. Phi means empty. Okay, there is no common point.
Mm-hmm.
Here also, when you will see the A has numbers and C has alphabets, so it will be also empty. This will be also empty. Phi, phi.
Mm-hmm.
This will be also empty. So these all sets, when two sets, or you can say events, does not have a single common outcome or element. Single common outcome, I'm writing in both the forms, sets as well as events, outcome or element in common, in common,
Mm-hmm.
then it is known as mutually exclusive, exclusive events. Means these all four, I'll give as number 1, 3, 2, 3, 4, and I'll give this as 5, the upper one. This has 5 intersection. So these all four, 1, comma 2, comma 3, comma 4 are mutually exclusive. Mutually exclusive events, whereas 5 is not mutually exclusive. 5 is not mutually
Mutually exclusive.
exclusive. Reason, because it is having 4 as a common outcome, as a common outcome or element. That's the way. Is it clear, Zaid? Mutually exclusive.
Mm-hmm. Yeah.
So now the conclusion, what's about the probability? So when an event is mutually exclusive, so when an event is mutually exclusive, then if if we have the conditions for, suppose, probability of A plus B. So if it is mutually exclusive, then only we can separate probability of A plus probability of B. What is the condition? If A and B are mutually exclusive, then only I'm writing in the statement form, then only we can separate the probabilities the probabilities along the plus sign. Is it clear, Zaid?
Sign.
If it is not mutually
Yeah.
exclusive, if I'll write it here, second thing, if it is not mutually exclusive, I'll give you the example tomorrow why it doesn't happen. If it is not mutually exclusive, then we cannot write probability of A plus B is not equal to probability of A plus probability of B. Is it clear? Yes or no?
Mm-hmm.
Right? So
Yes, it's clear.
equal explanation. So I think I must give you one example here. We'll take one example, not a problem. We'll see. Just I need to also known as disjoint, disjoint events or disjoint sets. Disjoint means what? No element in common. Okay.
Mm-hmm.
Okay. Wait a
Yeah.
minute. Yeah.
Content got it.
Yeah, you got a question. Give me one example also, so it will be more clear. My mouse vanished, man. Here's my mouse. That's A or B. That's plus is also known as, write it here. Probability of A or B. When or comes, or is also known as plus. A plus B. And if it is exclusive, and probability of A plus probability. We see one example. We'll see here only. Okay. No, we have to see, for suppose I have a sample space. 1, 2, 3, 4, 5, 6. Okay. Okay. And so this is powerless or like and I have A, for example, 1, comma 2. I have B, 3, comma 4, and I have C, for example, 2, comma 3. Okay. So what I'll do now, I need to calculate probability of A or B. Correct. So what is the probability of A or B? It is known as generally probability of A plus probability of B. Correct? Yes or no?
Mm-hmm. Yes.
So first of all, what we'll do, we'll calculate probability of A or probability of B. What does or means? A plus B, probability of A plus B. So we'll see, are they equal or not? Okay. So what is probability of A plus B? So how many elements are there in A plus B? 1, 2, 3, 4. Yes or no? 1, 2, 3, 4.
Mm-hmm.
Correct? So what will the probability when you calculating A plus B? So it is around, it will be 4 upon. So what are the total number of in the sample space? It is 6. So 4 upon 6, which is near approx 2 by 3. Yes or no?
Mm-hmm.
So now what we'll do, we'll find the probability separate wise. What is the probability of A? It is 2 by 6. And what is the probability of B? 2 by 6. So it is around 1 by 3 plus 1 by 3. So it is near about 2 by 3. Yes or no? So it is 2 by 3. Are they equal or not? Yes or no?
Yeah.
Yeah. Now what
Mm,
we'll do,
yeah.
we'll calculate probability of A or C. A or C. So can we do? Are they equal? Now there is a question mark here. Okay. Can we do probability of A plus probability of C? So A or C. How many elements are there in A
Probably
or
not
C?
gonna
There are one.
match.
Yeah.
I don't think they're gonna match.
Yeah. It's gonna match. You think it's gonna match?
No.
No, it's gonna not match. It's very simple thing.
I said no, it's not gonna match.
Yeah, so it is 3 by 6, so it is around 1 by 2. Okay, now I'll do probability of A, it is 2 by 6, plus probability of B also it's 2 by C. Probability of C also it is 2 by 6, so it is around 1 by 3 plus 1 by 3. It is 1 by 2. The question comes here, there is a question mark that I'm putting here. So it is around 2 by 3, so it is not equal to, therefore, if there is mutually, it is not mutually exclusive, then we cannot state it as correct. So here it is incorrect. So the reason you know why it is incorrect, because it is not mutually exclusive. Okay, Zaid, is this clear?
Mm,
Very much clear? Yes or no?
mm.
Interesting
Very
today?
much clear. Yeah, interesting. It's really interesting. Yeah.
Yeah. So what you can do, you can practice this sum in homework. Okay. We'll
Mm-hmm.
stop it here, and inshallah from tomorrow, two-way table and the general addition rule of probability and all, we'll be going to discuss the things. What we have seen, this relational based things and tables, or that we have seen in the first chapter for drawing the marginal and all things. Okay, general rule of
Mm-hmm.
addition and all, I'll explain you with best examples that I can give you, and it will be very much clear, inshallah.
Okay.
Okay,
Okay.
so that's
Got it.
see, Venn diagram is also come here. I've told you all these things will come. Okay,
Mm-hmm.
so assalamu alaikum, I'll share the recording. Okay,
Okay.
assalamu
Assalamu
alaikum.
alaikum.